is the order. Okay, so next one in our lineup is Pavel. So Pavel is going to talk about when small teams build big systems. Welcome, Pavel.
So my name is Pavel. I'm here in the capacity of an engineer. I'm a technical founder of Token Books. We're building an accounting software for Web3 companies and investors. I'm not going to talk about Web3 or show any tokens or anything like that. I'm going to talk about engineering, and my background is I worked mostly as a software engineer in my career. I was doing some data science, and the past maybe 10 years was managing engineering teams, and scaling engineering teams is hard. When you're building a startup, you actually don't want to scale an engineering team, but you also want to build something insanely complex, and in our case, it actually has to be accurate. And if you look at this market, the biggest complaint is that systems are not accurate. So if we're starting to build a system, we actually need to think from day one, can we call accuracy our competitive advantage? So here I will attempt to describe how we're doing this. We're a very small team, 4 engineers, started around a year ago. And so I was trying to summarize our engineering philosophy, so to speak, and it really comes from the habits and nature of software engineers and humans in general. You know, we're all lazy. In some cases, we can be paranoid, but if you're building an accounting system and use this data for submitting to governments, you probably have to be paranoid. Many of us are opinionated, right? And I will describe why it is important in our case. And we want to think that we're decisive and brave, right? So that's also one of the human natures. But here we try to use it in our advantage. So very quickly, what's the problem we're solving? Why you were even building this in the first place? You know, if you look at anybody looked at crypto software or has crypto? Do I have to go just a little bit? Some people, yeah. So basically, you know, especially here in Canada, if you have, or in the US, if you have crypto, or actually really any assets that change prices, you need to report taxes if you sell them. And then you have to compute the taxes, and in Canada there's one rule, in the US there's another rule, in different jurisdictions there are different rules. And so in this market, many systems look like you download the history of sells and buys, you label them, and you sum them up, query filters, sum them up, and you get your taxes. Unfortunately, that doesn't always work right, because if something was not labeled correctly, you want to change it. If the price was incorrect, you want to correct it. If something was missing because there was a bug in integration of some of the blockchains or upstream systems in your provider, you have to input it manually, so you're making a lot of changes. And then let's say CRA comes in and asks, how did you arrive at this number? And actually by law, you are supposed to explain exactly how you arrived at this number. And that's one of the complaints with the system. So we said, okay, can we actually attempt to build something more accurate with a very small team? That's a very small note. If anybody of you was involved with finance, you will appreciate it. We basically went all in with debits and credits. Why? Because for centuries, I think it's more than 400 years, this served as a very good tool to not make a mistake with money. So we thought, okay, maybe we should not be different and we should not invent anything new. So basically, the key thing here, if you buy a toy for $5, and 6 months later, you want to know for how much you bought that particular toy, and you want to be able, if you sell it, you want to be able to compute the difference. And if you bought 2 toys, which one did you sell? Actually, in the US, you can choose which one you sell. Let's say there are 2 equivalent toys. In Canada, you need to take the average price between the two. These are tax nuances, but you can see that knowing exactly what is your inventory is sort of important. And so debits and credits help here. So we actually want to build something accurate, and actually we need to now have double the number of finance information in the system. So it's more complex, right? And so here, I want to talk about, anybody heard about event sourcing? Yeah, okay. So it's a very fancy term, right? It's like everybody can throw it and say, oh, event sourcing, I'm smart. So that's not the point why I'm putting it here. I love event sourcing. I even gave a talk once to product manager why they need to explain their engineers why event sourcing is important. But I actually, as much as possible, I try to avoid it. But here, it's a very good solution for our use case. Specifically, we want to explain how the number was computed, and we want to be able to show basically at any point how was any change used in the computation of any particular cost basis, let's say, or tax. Or but then with event sourcing, actually, auditability comes for free. So if CRA comes in, all numbers are there. You just need to record. And replay, what is the replay? It's basically, somebody asks you to explain how the number works. You give them an Excel file, and they could, go and compare the numbers, run a report, or you can simply replay the history. It's like in a blockchain, right? You replay the history, you should arrive at the same number. It comes for free. But so now the question is, we have 4 engineers. We have a bunch of, close to 70 tables already in the system, so it's kind of getting complex. How do we stay sane and actually don't lose speed? And so here where my favorite animal comes in, lazy. So I like to say that I'm very lazy, but in what way? I don't like to do repetitive, boring work. So we basically created an internal framework for event sourcing, and all you need to do is to describe a command, and you need to describe the corresponding event as a class and a type, plug it into the system, and from React hooks to all the endpoints, to API keys, to logging, error handling, to audit logging, and even displaying the audit logs, you don't need to write any piece of code. And you don't even need to register this command anyway. It's auto-discovered. We use this pattern in a lot of places. JavaScript is very powerful for this particular approach. I don't know if anybody is using it. Basically, you create a file, name it a special way, and then you can create a function like 5 lines of code. It discovers all files like that, puts that in a static map during module load, and then just by name you can invoke any function with a strong type. Anybody uses this? Cool. Nice. I never used it before. We never used it before, but then we thought, okay, we don't want to write this code every single time. Can we do it? We do it in probably around 5-10 places in the system. And so what we got for free is we cannot forget, from type checking perspective, we cannot forget to assign a permission to do something in the system from our permission catalog registry. We have single API endpoint for all commands. We add a new class of a command, and it's available in UI right away. And if you want to show an audit trail, audit trails here, we basically just create trigger to display an audit log. We show it in a drawer on the right side, and we just say what is the aggregate, and everything is showing up automatically for free. And here how the command execution looks like. Basically, get the body. I mean, we obviously are skipping a bunch of steps here, but get the body, find the command, and just execute it with the access context of the user. And so, I was talking about paranoid, right? It's a little bit about storing all the history, but what happens when, let's say, you review the history of all your transactions and you realize that the price of certain asset on a certain day was incorrect for whatever reason, or you don't like it. Well, let's say there was a high volatility, let's say you bought Bitcoin for 25, but the system says you bought it for 20. You want it to be 25 to pay less tax. So you go and correct it, right? But then how do you explain to CRA? And then most importantly, when you change this value, actually everything after that has to be recomputed from scratch. And so with this system, you can take the history of everything and you can essentially build a computation graph deterministically in one single place for any type of change, and you can always invoke it knowing that it will consider everything in the same fashion and it will result in the same auditable log of events that can be displayed in the same way. Now, a little bit about the how we deal with complexity. When you're trying to be a good engineer, you actually overcomplicate, over-automate stuff, right? You make things, you over-engineer in general. But you need to move fast, you don't have time. So in a small team, you don't have resource. But certain things, this leads to mistakes if you cut corners, right? But certain things cannot be done in a sloppy way. You have to do it properly. So how do we manage this complexity here? We want to move fast and break things. It's a quote, famous quote, right? But in certain places we want to move slow. We have to move slow, and we want to break nothing. Because if we break something there, let's say in accounting computation, basically the whole product becomes useless. And one number computed incorrectly, you can submit the whole report for a year to CRA, so it's useless, right? So we integrated Rust and WASM for the math in the system, and why Rust? And do I have a slide for that? It's basically what we wanted is during the development time, we wanted somebody to yell at us if we were making a mistake. And so somebody is a compiler. TypeScript compiler is not bad. Rust compiler is fantastic in that way. And I don't know if you know, but besides, in comparison to other strongly typed languages, compiled languages, their compiler is also very friendly. It yells at you for many different reasons, many more than other languages, but it also explains you how to fix it, and that's very important. And so that's one of the reasons why we chose Rust. The second reason is it compiles nicely into WASM, and what we could do is we could use something like TypeShare, because we never copy-paste types. It's both lazy and paranoid, right? We can't afford to make a mistake in any field, so we just we take Rust types and generate TypeScript types, and then it compiles in the package, and some UI can actually show you an error if some field changed or something. So fun fact, TypeShare, anybody heard about it? Canadian product. It's a product of 1Password, but you heard 1Password, right? It's a Toronto-based company, so I think their founder built this library. It's not the reason we're using it, but it's fun. So we have thousands of lines generated like this, and it's insanely fast. So how about testing? Obviously, if you're building a finance system, you have to do a lot of testing, right? Well, we have a lot of unit tests. We actually have pretty good coverage. It's well above 50%, maybe getting to 70% in critical places. But when we started to model the stories, somebody bought an asset, then they bought a little bit more, and then they transferred it to another wallet, and then they sold a little bit. It's a story, right? And then you have to set up, all the boilerplate repositories, maybe databases, and everything. And so we found that a very simple test actually takes at least 150 to 200 lines of code. And given that we have around 20 different types of transactions, accounting transactions, meaning the type of operations that could be done from an accounting perspective, it's a little bit too much with the amount of code we're going to write. And also, TypeScript the tests are not very fast. And so we said, okay, we're very lazy. We don't know to write all these tests. And we also don't have time to run it. So what we can do? We said, okay, let's build our own language. Kind of a weird outcome. Who thinks it's strange? Yes, I agree. Even my team member thinks it's strange. I agree, but it paid off, and my only regret is that we didn't do it earlier. Because the outcome is that we have around 100 test files, which are pretty long in terms of, they're describing very complex situations, but the amount of code is, 10 is conservative, is probably 12, 15 times less the number of lines of code. And because we designed this language, we designed it in a way that it basically has the most minimal amount of language itself. So basically, it literally has DR and CR, debit and credit, as instructions, and then followed by the number and the account ID. So basically, you don't need to. It's not a Turing complete language. You cannot program, any program and run it. It's purely for tests. But the biggest benefit for us is that our accountant on the team, he actually can write these tests. He wrote the majority of these tests. He has engineering background, learned programming some time ago, and so he could write majority of these tests himself, and that actually eliminated the need to talk to the main user in English. We spoke to the domain user in our DSL. 2 minutes, awesome. And then we had to build VS Code extension as well. Then the other thing is we have all these tests, but obviously tests coverage, you can't forget a lot of things. So we thought, okay, we can't afford to forget or make a mistake. Right, so we would rather fail in production and show transparently to the user that, sorry, if something happened internally and we can't compute it, than give an incorrect answer. And then at least they can reach out to support and show the error, and then we can figure it out, or we can monitor it, right? So we basically implemented the same expectations that you would put in tests in production code. You just run the computation and then execute a bunch of checks. And if they fail, we just say which checks failed, and we show the error to the user. We uncovered a lot of interesting edge cases that we had to implement. So the takeaways: in a small team, we can build a relatively complex financial system if you implement these nice human virtues, right? If you stay lazy in a smart way. If you're paranoid for things that matter, if you're opinionated and you're standardizing things because you can refactor them later, and then if you're decisive, but maybe I didn't cover it very well in previous slides, but basically if you can reverse a decision, you just have to make it and move on. If you can't, like writing your own language, you sort of have to support it for all the months ahead. You better spend a good amount of time thinking about it. And the final lesson for our system is that it's sort of also the requirements. If you can't describe how you arrived at a number, you didn't really compute it. And so we just keep it always in mind, and whatever we're implementing new features, we're following this. That's it. I don't have a fancy QR code. It's a markdown file, so find me on LinkedIn if you're interested to learn more, or check out our website. Thanks.
Thank you, Pavel. I think we have time for one question, if there are any. Okay.
If it is not a secret, what's your ingestion source? Where from you ingest these events?
Basically there are around 400 blockchains in total, and there are hundreds of exchanges. So we do use indexing providers. So basically companies who compute the history and just give you by address. But we also use RPCs to cross-verify things, especially balance sheets.
Thank you very much.